Question number 61. The correct order of thermal stability of the given carbonates is. If you look at these carbonates, you will identify that these all are the carbonates of group 2 elements, and their thermal stability increases down the group. It means if I talk about magnesium carbonate, this is less stable. Then there would be the turn for the next one, that is calcium carbonate. After that, strontium carbonate would be there, and then barium carbonate. So down the group, if you're moving, then thermal stability of the carbonates of group 2 elements increases. So on the basis of that, correct order is clearly given here in option 2. So correct answer is option 2 for this question. Question number 62. Complete hydrolysis of NCl3 produces. If I talk about NCl3, in this case H2O you are adding here, that can be represented in this way. Here is the lone pair of electron on nitrogen. Chlorine has empty d orbital, so when H2O come in contact with it and it attacks, it gives its electron to chlorine in its d orbital, then it's a shifting of electron and it gets changed into this type of species plus in this way. This type of species formed here. This is unstable. Now further, there is the formation of this product along with HOCl. This way it is formed. Now further H2O will attack in the similar way, and now it will form NCl and H at these two sides, and this further results in formation of NH3, and each of this step there would be the formation of HOCl. Each of these steps there's the formation of HOCl here also and here also. It means ultimately it gets changed into NH3 and HOCl, and that's given here in option 1. That's why your answer becomes option 1. After that, there's another question. The paramagnetic species is or are. If I talk about paramagnetic species, it means those species which contain unpaired electron. And if I talk about NO positive ion, there are total 14 electrons in this species, and in its molecular orbital electronic configuration, there is no unpaired electron. That's why it is not showing paramagnetic behavior, it is showing diamagnetic behavior. O2 negative. If I talk about O2 negative, total 17 electrons are present, and if you fill these electrons in molecular orbital, you will find that in its anti-bonding orbital there is unpaired electron. So this is paramagnetic in nature. Further, NO. This also contains 15 electron total, and if you fill these electrons in molecular orbitals, you will find that in anti-bonding molecular orbital there is unpaired electron, and on that basis both 2 and 3 becomes the correct answer, because both of these species are paramagnetic in nature. Option 4 is the correct answer now. Question number 64. The alcohol which will be dehydrated most easily in acidic medium is. We have different alcohols given here. We should always know that dehydration of alcohol always follow the path in which carbonium ion is formed. It means SN1 pathway it is following, and there is the formation of carbocation. How it is formed, let's check. Suppose I'm talking about the first species, this one. Here is NO2. Now in acidic medium, dehydration you are doing, so it gets first form carbocation. So that carbocation would be NO2, and here's the positive charge. Now, due to the presence of an electron withdrawing group, that nitro group is electron withdrawing group, it will destabilize this positive charge. This carbocation would be less stable. While if I talk about the carbocation formed in this case, let's check what type of carbocation is formed here. A similar one. This is the carbocation and it is stabilized this is formed here. Further, if I talk about this species, here would be the formation of carbocation that I'm just drawing here. This way, methoxy group is present here. This group also has the positive charge in this way. Carbocation is formed here, and here also the carbocation is formed, that is positive charge here, and here is chloro group. Among all of these carbocations formed, this carbocation where this methoxy group is present at para position is causing most stabilization of this carbocation, because this is electron releasing group and it stabilizes this carbocation. Due to more stability of this is most easily dehydrated in acidic medium, and after dehydration it will form an alkene. You know that alkene would be this would be formed. So on that basis, option 3 becomes your correct answer. That states that this is the alcohol which will be dehydrated most easily in acidic medium. After that, next question. Question number 65. The correct order of stability of the given carbon ions is, it means carbon ion have the negative charge and we need that carbon ion which is most stable. In this case, we have to arrange them. One thing you should always know, that negative charge is stable on that carbon which has more S character, that is more electronegative. So on that basis, if I talk CH3, C negative charge. In this case, this carbon, that carbon is here, this is sp hybridized, more electronegative. It means this is most stable carbon ion. We have to check further options also. If I talk about the next one, CH2 double bond CH given in third one, this one. This is sp2 hybridized carbon. It was sp hybridized carbon. Less electronegative character is here. So this is more stable as compared to the second one. After that, let's take CH3 CH2. That is, I'm writing here, this is the carbocation, and this carbon sp3 hybridization is there. That's why this is least stable. Now, what about the compound given here as second one? Let's check this one. In this case, it is CH3, C double bond O, CH2 negative. Though this is sp3 hybridized carbon, but it is most stable. In this carbon ion, there is resonance. This is resonance stabilized. This can also be written as this way. This charge dispersal is there. This negative charge comes here in this way. So due to the resonance, it becomes most stable. So what would be the correct order? The correct order is first, second, that is most stable. After that, there would be the turn for fourth one, then third one, and after that, it's a turn for first one. Where this order is given 2, 4, 3, 1. This is correctly given in option 3. So that becomes my correct answer. After that,